Hi, this is Thomas from Apex Game Tools. In this video we'll be looking at the load balancer again, and in this second video on the load balancer we'll be looking at how you can utilize the load balancer yourself for executing actions. If you haven't already seen the first video on the load balancer, I suggest that you see that, because we cover how you configure the load balancers, the purpose of the load balancer and so forth in that video, which is helpful for understanding this video. So let's have a look at how you can actually use the load balancer for your own purposes. Now there are a few different purposes that you may use it for. The first is you can create custom load balanced items that can live in the load balancer and be executed by the load balancer. Second option is that we have some utility classes that you can use so that you can describe what we call a one-time action. A one-time action is an action that will execute once, but usually you will execute it with a delay, and you can use the load balancer for that. You could also have a continuous action, or a repeatable action as it's called, that will repeat a certain action for a given amount of time, or forever. And lastly, you could have a long-running action where you would want to distribute the workload across several frames instead of eating up the entire budget of a few frames. In addition to that, we also have the option to marshal actions from other threads onto the main thread of Unity. So we'll start looking at these, each of them in turn. We'll see some script and we'll see some examples in Unity. So first up, we'll look at having a custom load balanced item that you can schedule with the load balancer. For this, we'll use the example from the first video where we had this script attached to pillars, which would toggle them up and down. And as you can see, that is the script we have here. In order to implement your own load balanced item, what you need to do is simply implement idle load balanced. Now in this case, this also derives from mounting behavior. This is simply because that is how we used it, attached it to a game object, but that is not required. I mean, anything can be a load balanced item. You simply have to implement the idle load balanced interface. And it consists of two things. It consists of a repeat property. The repeat property controls if the items should be repeated again and again. So you can either, as we do here, return true, which means they will just repeat forever until it is removed manually. Or you can put in some conditional logic in here that will end it after a given amount of repetitions or whatever. It's completely up to you. The moment you return false from this property, the load balancer will remove it from the queue. Now the second thing to implement is the method called execute update. As you can see, the signature, it takes gets a delta time, which is the time it has spent sitting in the load balancer, and it also gets a next interval, which is the interval which the task will be executed at unless changed. And then it will return a nullable float, so either you can return null to simply use the next interval, or you can return some other interval if you want to change up the intervals. Now the implementation of this method is not important at all. You can do whatever you want in here. This is executed at the interval specified either when you add it to the load balancer or the default interval on the load balancer as it is configured in the inspector. And as you can see, now the only thing that is a little bit important here is what you return. Now, as I mentioned, you can return null. This means that it will simply use whatever it has been configured with as the interval between executions, or you can return some other interval which will then it will then use that interval for the next execution. So that's it. That's all you need to do, and then obviously you need to add it to the load balancer somehow. In this case, we do that in enable, and on disable we remove it. As you can see here, we simply add it. In this case, we use the default load balancer, You could use whatever load balancer you want. Obviously, you should only use either the default or some load balancer that you have defined yourself. You should avoid using one of the reserved load balancers that are used by Apex Path internally, such as steering or dynamic obstacles or scanners and so forth. We will touch on how you create your own load balancers just after this. So that's it for the custom items. Pretty simple. We don't have an actual example of that. That is what we showed in the first video. So if you haven't already, then look at that. Now, as mentioned, I will just look at how you create your own load balancers as well. As we also saw, let's just switch back into Unity. In the last video, we had these two extra load balancers. These will not be in your project normally. This is because we have defined those for this examples project. So in order to do that, it's pretty simple. I have created a class. I've derived it from load balancer. That is required. And then I have implemented two additional load balancers. Now, one I've done by means of a static read-only field, and the other one I've used a static property. Whatever you use is up to you. This enables you to configure it as well, so this is the preferred method. And simply what you do is define a public static read-only field with some name, and then you assign that to a new load balance queue, and then you can configure that queue however you want. And obviously the arguments for the queue corresponds to what you will find in the configuration in the inspector in Unity. So you can basically set up the default so that they will appear differently as from here. As you can see in here, we have 10, 1, 24, and if we go back into Unity, we'll see that on our examples load balancer, the update interval is 1 second instead of the default, which is 0.1 second, and we didn't have updates per frame 20 and updates per millisecond 4. So that's how you create your own load balancers. One thing to know about having multiple additional load balancers is that they each have their own budget. So as you can see, they each have this budget on how much time they can use per frame. So the default load balancer by default has 4 milliseconds to use per frame, and then the others have some other or possibly the same budget. So if you have too many, then you basically get to have a rather large budget combined for the load balancers, which means they can use quite a bit of the frame for doing various work. Now, if most of your work is actually done in load balancers, that's just fine, but just be aware that they each have their own budget, so you should set it accordingly. So let's move on to the next example. This is the one-time action. Our one-time action represents just a single action that you want executed just once. Just fire and forget, basically, but typically, obviously, it's something that you want to execute sometime in the future. You can execute it right away in the next frame as well, but that is also sometime in the future. You will never be able to execute it synchronously, because that will basically, you might as well just call the method then. So pretty simple example. As you can see, how you do it is you instantiate a one-time action. It takes an action with this signature as it's one argument. This is what you want to execute. Now the delta time is the time that it has been sitting in the load balancer. Usually for one-time actions, this is not really needed for anything. You won't really be interested in this, but if you are, then this is what you get. So basically, this is the delay by which you have scheduled it. So if you schedule it to run in 1 second, then this will have 1. So you instantiate that and then you add it to the load balancer. Now there are multiple ways to add it to the load balancer. In this case, we added to the example load balancer that we have created for this, and we just added it with the simplest method possible. Just add the action directly without having any configuration at all. So this means that this will actually use the default configuration of the load balancer, so the default interval and so forth. But since this is a one-time action, the interval is typically not relevant. So what this will do is basically execute the one-time action as soon as it can, because it will not delay the initial execution. So this will be executed on the next frame. For the next example, it's a little more complex. As you can see, we define the action instead of using an instant method on the class. We define the action inline here using a lambda. So we make a one-time action, and for the action itself, we simply debug log how long it has been sitting in the load balancer. Again, we take this float argument, which is the delta time. In this case, we added using an overload of the add method. As you can see, we add the action and then we also specify some configuration for it. So we added with an interval, not the default interval. Instead, we added with a 2-second interval, and we also tell it that we actually want to delay the first update. Now the interval itself is not really relevant since it is a one-time action, so it will never run again. But it is relevant since we will actually want to delay the first update, and it will then use this interval to delay the first update. So it will delay it by 2 seconds. So that's how that is one way to execute a one-time action, using it and explicitly using this one-time action class. So let's just see that in action real quick. The one-time action, we have that already. So if I press 1, as you can see, we will have it done immediately or on the next frame. And when I press 2, it will delay for 2 seconds, and then it will execute, as you can see. Pretty simple. Next up, we have the repeatable action. The repeatable action is an action that you will want to execute at an interval, either for a set amount of intervals, or a conditional amount of intervals, or forever. So let's start by looking at that example, and then we'll look at the code. So as you can see, we have 3 examples of execution, and then we have a way to stop it as well. The first one is called fixed repetitions 5 times. We basically schedule an action, repeat it 5 times, and then that's it, at the default interval set on the given load balancer. The next option is to have conditional repetition. It will repeat every 2 seconds with an initial 3-second delay, and then it will continue while a certain condition is true. And finally, we have simply an indefinite execution of something every 2 seconds. And finally, we have an ability to stop the execution, which can be needed for at least number 3. So let's just quickly see what they do. Very, very simple. As you can see, they just execute. This one executes by the default interval, which I believe is 1/10 of a second. No, sorry, it's every 1 second. That's the default of the examples load balancer. And if we do number 2, it will start, as you can see, after a 3-second delay, and then after that it will execute every 2 seconds for a number of repetitions, which is conditionally evaluated. And finally, we have number 3, which is simply just working forever, and it will just work. As you can see, this one wasn't delayed at all, so it executed on the first frame possible, and after that it will execute every 2 seconds. And it will just continue executing for as long as it's running, or until I tell it to stop, which I'll do now, and then we'll look at how this is implemented in the code. So back in the code, here we have the repeatable action. It works very similarly to the one-time action. As you can see, it's called repeatable action, and it takes, in this case, instead of an action as a parameter, it takes a function. This is because the evaluation of whether or not it needs to continue is actually controlled by the action that it executes, or the function that it executes. So one of the functions that we have defined here is on an instance that do work here. As you can see, it still gets this delta time, which tells us how long it has been sitting in the load balancer between its execution. So this is usually, the interval. And then it will return a boolean. Now the boolean it returns determines whether or not it will continue working, in addition to other conditions. So this will, if this ever returns false, then it will stop working from then on. So it will remove itself from the load balancer as soon as this returns false. So now for the first example, as we saw, it repeated for 5 times, and but it uses this method here, which will always return true, so it will never stop this way. But instead, this one has an overload for the constructor that you can simply tell it how many repetitions you want this action to execute for. So this is a fixed number of repetitions, and we just add it to the load balancer, same as before. On the second option, we had a repeatable action where we had a conditional on when to stop executing. So as you can see, we again create a repeatable action, and this time we just pass it a function using a lambda. We do not pass it a fixed number of repetitions. We only pass it the function. So the function itself controls how long it will repeat for, and as you can see, it will repeat for as long as the count is less than 5. So yeah, and that count is incremented up here, as you can see. So as long as the count is less than 5, this will repeat, otherwise it will stop. And then we have the repeatable action that just continues forever. And as you can see, it's very similar to the first one, but instead of returning some conditional with a counter, it simply returns true all the time, which means that it will repeat forever. Now this one, when we add it to the load balancer, we actually get a hold of a handle that is returned from the add function on the load balancer, and this handle we can then later use to control this particular action on the load balancer. So in addition, as you can see, we can stop it, but in addition to stopping it, we can also pause it and resume it. So that's it for the repeatable action. Next up, we have a long-running action. Now long-running actions are basically tasks that take some time to execute, and then if you execute them just in the normal method, as normal, they will use up too much of a frame budget, and maybe cause some spikes or some dips in the frame rate rather. So you want to avoid that typically. So what we have here is basically an action that takes some time to execute, but we will only allow it to execute in this case 3 milliseconds per frame, and then it will take as long as it takes for it to finish using that much per frame. So let's have a look at how that works. So when I press 1, you can see it actually did it. So not much information to see there. But what we can do is we can look at the profiler to see what actually happens. So having the profiler open, I'll now press 1. And then we can go in here and we can stop. You can see we have some code executing here. And the load balancer is updating, as you can see, and it is using 3 milliseconds, and it will do so for a number of frames, and then at some point it will stop, and then it's done with the long running action. So how do we achieve that? Well, not surprisingly, we have something called a long running action, again similar to the first two. Again, this one has some overloads on the constructor. It takes, in this case, again a function, but this function, instead of returning a boolean, it will return an I enumerator. So this is, similar to how a coroutine works. So basically what you want to do is the work you need to do, you want to yield return null from it every once in a while, so that it basically allows the load balancer to skip to the next frame before it continues. So as you can see, what we do here is we do 100,000 raycasts, and after each one we return null, and then this allows the load balancer to control how many of these raycasts are done per frame. So we schedule it as we can see here. Create a long running action. We pass it how many milliseconds it is allowed to use per frame, and then we add it to the load balancer. And again, as before, we get a hold of the handle so that we can actually stop this long running action if we should want to do that before it's finished. Now, as you can see, we also added to the load balancer using an interval of 0. This basically means that we actually want this long running action to execute every single frame until it's done. So we want to allow this load balancer to execute every frame using 3 milliseconds per frame. Alright, so next up we have some shortcuts to the 3 we have just covered. Now, these are called pooled actions, and this enables you to basically call a method without having to instantiate these different types of classes yourself, and then you can execute. It will behave exactly the same, or it will just be easier to cope with, and it will be pooled. So basically the action is instantiated once, and then it is reused for further execution. So these basically do the same as the others did. So we'll just skip the examples showing those. They just output stuff to the console. That's not super interesting. So let's see how it's implemented instead. So here we have a number of different examples. Again, we have some instance methods that we use to do some of the work. We have one here, we have a function here, and we have a long running here. So as you can probably guess, these correspond to the ones we have been through before. This is for a one-time action, this is for a repeatable action, and this is for a long running action. Now, so how do we do this? Well, we do this via some extension methods on the load balancer itself. So to execute a one-time action, you simply call execute once, and then you pass in whatever action you want to execute. Obviously, you can also do that using a lambda. And you can also do so using some different overloads, which will allow you to put in some delays or some other intervals. In this case, obviously, for execute once, there are no intervals, but you can put in a custom delay. The repeatable actions work the same way. In this case, we have an execute method, which takes, in this case, then a function, with a Boolean return value, and it will then control how long it runs, as we saw before with a repeatable action. This is just a little bit easier. You simply pass in the function that you want to execute, and then it executes. Down here we've done the same thing, just using a lambda instead of an instance method. And again, we have put in a delay, and we have also put in some additional configuration about an interval, and we have also put in that we want to delay the first execution. So a custom delay of 3 seconds, and we want to delay the first execution as well. And as you can see, so this one is conditional on something else, this is conditional on time, so this will basically run for 10 seconds and then it will stop. And then we have our long running actions. Same thing, an execute method. You simply pass in the enumerator that you want to, that is representing the long running action, and then it will run until it's done. Now, for all of these, as you can see, we get the hold of the handle, so that we can actually stop it. This is obviously this is optional. You don't have to get a hold of the handle if you don't intend to stop it, but you can do if you want to. You can also, as I mentioned, pause and resume. So that's it for using pooled overloads, or extensions to execute on the load balancer. As a final topic, we will be looking at the marshaller. The marshaller has a different purpose than the other load balancers. The marshaller basically allows you to marshal an action from another thread onto the main thread. So this is useful if you have stuff that you cannot execute on another thread, such as Unity stuff, and you want to execute that on the main thread. So let's just see that as a quick example here. So the first one here, this is going to perform a Unity action on the main thread. If I press 1, and I'm going to get an exception because I cannot access, in this case it's time, the time object, I cannot access that from another thread. Instead, if I press 2, I actually get to see what the time is. So let's just have a look at that, how that works. So as you can see, I have my method here. I want to do something, my action, and what I want to do is I want to debug log what the time is using time.time, but this particular construct does not allow me to access it from another thread. And this is what I do up here. I simply try to do that directly. I simply start a thread and try to do stuff that is not allowed, as we just saw. So instead what I can do is I can use the marshaller to execute this on the main thread instead, which will do that on the next frame, and it will then be allowed. So you can use this from other threads to execute stuff that you would otherwise not be able to do. So that's all there is to say about the load balancer. Obviously all of these examples are available in the examples project, so you can find them there and try them out. See you in the next video.